All right, this other proof here, it's a little easier than the last one. What we do here is we look at basically what we're given here. So I'm going to write down and say, well, what I'm given is basically that AC is congruent to CE and ED is congruent to AB. I'm going to go ahead right away and just say that these two guys are equal. It just makes it a little easier. So I know that ED is equal to AB. And the reason is the definition of congruent. Now, from here, they ultimately want me to get CD is congruent to AB. And if you look at CD, or pardon me, BC, they want me to get that these two guys are congruent. We know here that ED is congruent to AB, and we know that the big one, AC, are congruent to each other. So you can tell I'm going to do a segment addition here. Here's this first step there. Right away, I'm just going to go ahead and say that AC is equal to AB plus BC. So let's write that out here, that AC is equal to AB plus BC. Similarly, I'm going to say here that I guess it would be CE. This is equal to AB. Pardon me, CE is equal to, not AB, I guess it would be ED, pardon me, ED plus DC. Okay, so CD plus DC. Okay, so you get something like this. And this is, again, the segment addition postulate. Okay, so you end up getting something like that. Why is this useful? Let's take a look. I ultimately got to get that CD, okay, or this guy right here. There's CD, and here's BC. So I know those two. What else do I know here? Well, I know that CE is equal to AC. So because these are equal, I can in fact say here, let's see here, I can actually set that AC is equal to ED plus DC. Because again, I can substitute, instead of CE, I can substitute AC. And that's a substitution property of equality. Next, I'm going to get here that I can actually set these two guys equal. And so what I'm going to get here is that I got that AB plus BC, this is equal to ED plus, instead of DC, in fact, I'm going to rearrange that and just call it CD. It's okay to do this. I'm going to call that CD. The reason I'm doing that is just so it looks a little bit more like what I want to prove. That's going to be, again, a substitution property of equality. And so I end up getting something like this. Now how do I get rid of, I need CD and BC, so I need these two, but I need to get rid of ED and AB. Well, it turns out ED and AB are the same. And so I can do one more substitution here and say that AB plus BC is equal to AB plus CD. And that's one more substitution property of equality. Now I can subtract from both sides, and I'm going to get here that BC is equal to CD. And again, that's a subtraction property of equality. I notice in here that it's actually flipped, so let's do a symmetric property, and let's say that CD is equal to BC, and that's going to be a symmetric property of equality. And last but not least, let's say that CD is congruent to BC because of the definition of congruence. And we're finished, and we've proven our point.